Good morning, guys. Today we're going to be looking at solving cube root equations. Last class we were looking at solving square root equations. So now we're looking at cube root. Equations with cube roots or fractional exponents of 1/3. So now we're looking at things so cube roots have a fractional exponent of 1/3. So just like last class, the square root had a fractional exponent. A cube root also has a fractional exponent that have variables within the cube root symbols are called cube root equations. We can solve cube root equations by raising both sides to the third power. So last class we were raising both sides to the second power. Now for this topic, dealing with cube roots, we're going to raise it to the third power. So that's one of the changes that's happening in the lesson today is now we're using the third power. Another change that happens is in the steps. So if I look at the steps, I need to isolate the cube root term. So that could be, the term that has the cube root, which is the 3 in front with an x, or it can be something that's raised to the power of 1/3. Because if I write it like this is cube root, this is also cube root, and make sure that it's on one side of the equation. So this is kind of the same idea as last class. Just instead of working with the number 2, we're working with 3. Now there's something else that changes. If you notice, there's no step. There's 3 steps here, when before there was 4. There was a step, if you remember from last class, we had to check if it was equal to a negative. So let me write that actually. So last class we were checking, if it's equal to a negative, a positive, or 0, then we would say negative, there's no solution, or positive and 0, there's a possible solution. But now for cube roots, it doesn't matter if it's positive, negative, or 0. All these situations have a possible solution. And again, this is only for cube roots. So for cube roots, specifically for cube roots, we don't have to worry about negative, positive, or 0. So that would move us to the next step, which would be raise each side to the power of 3 and then solve the equation. All right, so let's take a look at the example here. And first step is isolate the cube root. Okay, so then we have the cube root term is right here. It's already isolated. Okay, so then step 2 says raise both sides to the third power. Okay, so then we're going to write, copy the left side and put it to the third power equals 2 to the third power. So this is step 1, step 2. And then what happens when I raise both sides to the third power? You should notice that the cube root and the cube cancel out, right? So if they cancel out, that leaves me with x equals, and what is 2 to the third power? That's 2 times 2 times 2. That's 8. Okay, so we have step 1. We have step 2. Well, it already has a 2 there, so I'm just kind of matching them. And step 3 is just solve the equation, right? And this would be step 3. Okay, so breaking up the steps, right? We got step 1, step 2, step 3. All right. Let's go over to example 2. Okay, so step 1 is isolate, oh, I don't even know what I'm spelling there. Isolate the cube root isolate the cube root. So the cube root is right here, so I want to isolate that one. So I need to add 7 on both sides. Just cancel. I get y to the 1/3 equals -3. Right, -10 plus 7 is -3. Step 2, raise both sides to the 3rd power. Okay, so if we raise both sides to the 3rd power, we can basically going to write the same thing again. Just put 3rd power there and -3 to the 3rd power. And let me fix this 3 right there just so we make it a little bit clearer. Okay, so what happens with the 3 and the 1/3? They're going to cancel out, leaving us with, so again, right, they're going to cancel out like this, right? So they're going to cancel out, and I'm going to be left with y. So I'm going to be left with y equals, and so what is this? What is -3 times -3 times -3? Well, -3 times -3 is +9. And then 9 times -3 is -27. Right? Oh, I forgot to put here. The last step after we raise both sides to the power of 3, we solve the equation. So we have step 1. We have step 2, and then we have step 3. Okay. Let's go over to example 3. And let me zoom in here. Yeah, that looks good. Okay, so step 1, isolate the cube root. Isolate the cube root. So the cube root is right here, and I want to get that by itself. So notice what I have around it. I have a times 3, and I have a minus 5, and equals negative 8. So I want to add 5 on both sides. It's going to give me a negative 3 equals 3 times the cube root of m plus 20 . And then I need to get rid of the 3 here, the times 3. So I'm going to divide, opposite of multiplying by 3 is dividing by 3. So when I divide, negative 3 divided by 3 is negative 1. These 3's will cancel, leaving me with the cube root of m plus 20. There we go. That's step 1, right? Step 1 is done. Step 2 is raise both sides to power of 3. Okay, so that's going to look like negative 1 is the third power, and then cube root of m plus 20 to the third power. And if I work it out, what's negative 1 times negative 1 times negative 1? Right, negative 1 times negative 1 is a positive 1. And then a positive 1 times another negative 1 is a negative 1. Then we're going to see that the cube root and the cube are going to cancel, leaving me with m plus 20, right? Okay, so I'm going to be left with m plus 20. All right, so that was step 2, right? This was step 2 here. Step 3 is solve the equation. So solving, I can just subtract 20 on both sides, giving me negative 21 equals m, or I can write, m equals negative 21. It should take both answers. And so that's step 3. All right, example 4. All right, step 1 is I isolate the cube root. Well, if I want to isolate the cube root, it's already isolated actually on both sides. So when that happens, that is step 1. So copying this, that's already step 1. Step 2 is the raise both sides to the third power. Okay, so how does that look? It's gonna look like I'm just copying the same problem again, but just putting putting a power of 3 on both sides. That. All right, so that is step 2. Okay. So what happens after you raise both sides to the third power? You should notice that the third power cancels the cube roots. So we're left with everything inside the cube roots. 11n minus 15, and we're left with n plus 9. So then step 3 is just says solve the equation. So to solve, I need to get all the variables on one side and all the numbers on the other. So I can either, move the n's to one side, the numbers. It's up to you what you want to move first. I would move the n first. So subtract n. 11n minus n is 10n's. These cancel here. I'm left with 9. Then I would add 15 on both sides. Then I get 10n equals 24. And then how do I get rid of the 10, right? The opposite of multiplying by 10 is dividing by 10. Oh, but can we divide 24 by 10? No, but can we reduce it? Can 24 over 10? Let me write it a little bit lower down here. Can I reduce 24 over 10? Well, both of them are divisible. Both of them are divisible by what? They're both divisible by 2. Right, you can divide both of them by 2. So if I divide 24 by 2, that's 12. And 10 divided by 2, that's 5. So if you come to a situation where you have to divide, make sure that if you can't divide and get a whole number, make sure you simplify the fraction. So simplified answers. So it's 12 over 5. All right. Now, I'm not going to skip number 5 today. Right. So there it is. Number 5. So if we put down the steps, isolate the cube roots. Isolate the cube root. Where is the cube root? It's right there. So there's a couple things happening around it, right? It's being multiplied by -2. It's being subtracted by 10. And there's a -20 on the other side. So I can add 10 on both sides. And then that gives me -10 equals -2a to the power of 1/3. Then the opposite of multiplying by -2 is dividing by -2. And so that gives me -10 divided by -2, that's a +5. These cancel, and I'm left with a to the power of 1/3. And I'm going to rewrite it just a bit. You can keep it in the order that it is right there, or you can rewrite it like I'm doing now. But this would be step 1. Okay. Step 2. raise both sides to the power of 3. Okay, so that would look like a to the 1/3 to the power of 3 equals 5 to the power of 3. So that is step 2. And then step 3 is just solve the equation. So if I solve, the third power and the 1/3 are going to cancel, leaving me with a equals, well, what's 5 times 5 times 5? I know 5 times 5 is 25, and 25 times 5 is 125. Okay. Awesome. So that's covering the first 5 examples. And then the last example, 6, is the graphing one, the graphing and solving combo. So let's look at example 6. Same idea as last class. We're talking about the idea that when we talk about zeros, it's another way of saying x-intercepts. And when we talk about solutions of the cube root equation, we can also call them roots. It's again this terminology aspect of it, right? So let's look at the graph. Let's see if I can zoom in here, so we can focus on the graphing part. Okay. And so we're going to use the rules of transformation, right? I have x plus 2, so that means move to the left 2, and then minus 3 is outside. That means we're going down 3, and then the 3 in front here that's being multiplied, this is a expansion. We're expanding by 3. So again, the expansion part is, well, we need the table here. So let's say I have a table for the cube root. If you remember the cube root table, that's -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. And so what the expansion is doing, right? Because if I have the parent function points, let me use a different color here. Let's use gray. 8. Okay, so these gray points, these are the parent function, but what is the expansion doing? So it's multiplying all the y values times 3. So that's going to give me -6, -3, 0, 3, and 6. So how's that going to change the graph? Well, it's going to make it look like this, like the following. So it's going to go down to 3 here, up to 3 here, over here at -8, instead of going down 2, it's going to go down 6. And then over here, it's going to go to oops, 6. Okay, so there's this expansion of the points like that. So let me go ahead and erase the gray points so we can focus on the points that we are going to move and graph. So now that I've done the expansion, this is the shape now of the graph. It's kind of stretched out vertically. And now we're going to move all the points to the left 2 and down 3. So let me start with the center point. I'm going to go 1, 2 in green, if you look at my green markings, and then down purple. Right, 1, 2, 3. This is my graph. So I'm taking the center point, moving it 2 to the left and 3 down. But I'm going to do that with all the points, right? So if I do that with this point here, right, to the left 2, down 3. Do that with this point here, 1, 2, 1, 2, 3. And then 1, 2, 1, 2, 3. And the last one, that one kind of goes out of the area, right? 1, 2, 3. Let me zoom out a little bit. And yeah, and so there we go. So again, the red, what happened with the red is there was an expansion of points spreading up and down. And then the green and the purple markings tell me which direction I moved, how many steps I moved in each direction. So let me just keep everything that's blue. Make sure and erase everything that I do want to erase is erased. There we go. All right, so this is my graph, a cube root graph. Let me zoom out here so we can see the whole question. And, oh, sorry. So it's asking about the zeros. It's asking about the zeros. That's the x-intercept, right? The x-intercept of what? The zero of what? Well, of the function. So I'm going to copy the function, x plus 2 minus 3. And where is the x-intercept? Where does this blue graph intersect the x-axis? Looks like it intersects right there at -1. Oh, sorry. As x equals -1. All right. So now let me zoom over to the equation and let's solve this equation using the steps that we've done so far. So I want to isolate the cube root term. So I'm going to have to add 3 on both sides. I get 3 times the cube root of x plus 2, these cancel, equals 3. Then I'm going to divide both sides by 3 to cancel this 3 and this 3. And that's going to leave me with the cube root of x plus 2 equals 1. And then the next step is to raise both sides to the power of 3. So that's going to cancel the cube root and the cube. X plus 2 equals 1. Right? 1 times 1 times 1 is 1. And then subtract 2, x equals 1 minus 2 is negative 1. Okay, so we have that the root of, and I'm going to copy the equation, is what? The root is negative 1. So we have this terminology again, the same as the last notes. When we talk about roots, we're talking about, solutions to the equation. So whether we're graphing, right, whether we're graphing something or we're solving something, but those two things have the same equation. In one aspect, we're just graphing it as a function. On the right, we're setting that function equal to 0 and solving. When we set the function equal to 0 and solve, we're finding the roots. We're finding the x-intercept. The 0, we're finding the solutions. And they should be the same. All right. Well, that concludes our notes. I'll see you guys in class next time. And thank you for joining me.